Hey everyone, welcome back. This is part 2 of the video for chapter 10, problem 4, I believe. Yep. So what you see here is the diagram for the problem that we're doing. So let's get back to what we were talking about, which was we have a strategy for solving this. We're going to use equations 3, 4, and 5 to obtain the three currents in terms of two unknowns, I1 and I2, and then use equations 1 and 2 to solve for those. So let's get moving on that whole issue. So let's start with equation 3, which we have right here. So let's rewrite this. So we have 3I3R minus 4I4R equals 0. The r's are common to both, so they can be canceled out. And what you get is 3I3 equals 4I4. And so you could write this any way that you so choose. You could write this as I3 is equal to 4/3 I4, or the reciprocal of that, where I4 is 3/4 I3. I'm not going to write both of those out. Okay, so now let's go to equation 4, which says that I1 plus I2 is equal to I3 plus I4. So we have I1 plus I2 is equal to I3 plus I4. Now, if I want to write I3 in terms of I1 and I2, then I plug in the fact that I4 is equal to 3/4 I3, so that equation becomes I1 plus I2 is equal to I3 plus 3/4 I3, which even I can do this math. That gives me 7/4 I3 on the right hand side. So crossing all the T's, dotting all the I's, what you get is that I3 is equal to 4/7 I1 plus I2. Now, a shortcut to finding I4 is to know that I3 plus I4 has to equal I1 plus I2. So that must mean that I4 is equal to 3/7 I1 plus I2. Now, you could have just done it the longer way. It's essentially the same thing, but want to save some time so that we make the 20-minute threshold here. Now, use equation 5. And that one's going to say that I4 is equal to I1 plus I5. And what I want is I5 at the end of the day. So I5, which is the current on the bottom wire, is equal to I4 minus I1. Now, plugging in what I4 is in terms of I1 and I2, you get that this is 3/7 I1 plus I2 minus I1. So the I2 remains unchanged, but there's a factor of I1 multiplied by a fraction and subtracted by I1. So you get 3/7 I2. And then 3/7 I1 minus I1 is minus 4/7 I1. And that's what I5 is equal to. Okay, so at the end of the day, what we need to find is I1 and I2, and then we can solve for I5. So let me just write that down completely. I5 is equal to 1/7 times 3 times I2 minus 4 I1 So this is an important equation that we're going to want to come back to. So find I1, comma, I2. Very nice. Okay, so now we have to go to the difficult business of finding I1 and I2. So from equation 1, what we have is that E minus I1R minus 4I4R is equal to 0. Okay, and we want to find I1 and I2. So let's rewrite this using the fact that I4 is equal to 3/7 I1 plus I2. So we're going to plug that in there. Okay, that's certainly gonna make things a little bit more tedious. In equation 1, what we're gonna want to do is rearrange things slightly so that you've got E is equal to I1R plus 4I4R. You can divide by R on both sides, so you get E over R is equal to I1 plus 4I4. And now we can plug in what we had for I4, which, so we rewriting this as I1 plus 4 times, let's put that in parentheses, I4 was 3/7 I1 plus I2, so this is 3/7 multiplied by I1 plus I2. So putting that all together, you've got I1 plus what looks like 12/7 I1 plus 12/7 I2. And then combining the terms with I1 together, that's going to give me 19/7 I1 plus 12/7 I2. Okay, and I just want to rewrite that to make it nice and obvious what's going on. E over R is equal to 19 over 7 I1 plus 12 over 7 I2. Okay, so that's one of the equations that we want to work with. In principle, we could just solve one of these right now, and in fact, that's probably what we're going to end up doing. But let's write out the second equation as well. From 2. So the second equation looks something like 2E minus 2I2R minus 3I3R equals 0. Let's rearrange this somewhat just to make it easier to look at. I think that that's very important to just make sure that it's simple to look at something, because otherwise I think it makes things more confusing. It's like the equivalent for me of turning down the music when you're looking for a particular address. So rearranging, we have 2E is equal to 2I2 times R plus 3I3 times R. Now we can divide by R on both sides. You get 2E over R is equal to 2I2 plus 3I3. Now use the fact that I3 is equal to, if I remember correctly, 4/7. Yes, 4/7 I1 plus I2. So now we're going to have to plug that monster in there. So we get that 2E over R is equal to 2I2 And just to give myself a little bit more breathing room, I'm going to put the extra term down below it. So this is 3 parentheses times 4 over 7 times I1 plus I2. Or this is 2I2 plus, this is 12 over 7 I2 plus 12 over 7 I1. Now combining like terms means that I'm going to make the first term into 14 over 7. That's equivalent to 2. And then add it to 12. So this is going to be 26 over 7 I2 plus 12 over 7 I1. So, and then the left-hand side had a factor of 2. So when you divide that on both sides, you get that this is 13/7 I2 plus 6/7 I1. So this is the other equation that we very much want to work with. So we have the two equations basically in their most simplified form. So let's go ahead and work with that. So we can write a new equation A, which is just equation 1, or not equation 1, but the, so let me just specify which one I'm talking about. This equation right here, let's rewrite this one. I'm just going to multiply by 7 on both sides because I don't want to work with those fractions. Oops. So, working through that, we're going to see this is 7e over r is equal to 19I1 plus 12I2. And equation B is going to be 7e over r equals 6I1 plus 13I2. Now we want to solve for, let's solve for I1, which means that what we're going to do is solve for I2 in terms of I1 and then plug that. So from A, we are going to solve for I2 in terms of I1. So I don't want to move down too much. If I solve for I2 in terms of I1, what I get is 12I2 equals 7e over r minus 19I1. This is what I mean by solving for I2 in terms of I1. And then I divide by 12 on both sides. So this is I2 is equal to 7/12 e over r minus 19/12 I1. That's a function for, that's I2 as a function of I1. And now we are going to plug this into equation B. And what that means is that we're going to have 7e over r. This is just equation B, 6I1 plus 13I2. But now I'm going to plug what I2 was. So this is 13 times 7e over r over 12 as well, minus 19/12 I1. And now I'm going to want to solve this for I1 in terms of the parameters we know, which are the EMF and the resistance R. So this is going to involve me simplifying this sum until I can get I1 as a function of those things. Just writing this out a little bit more clearly, what we have is 6I1 plus 91 over 12 E over R minus 247 twelfths I1. Now we want to combine those two terms. So what this ends up becoming is 91 twelfths E over R minus 175 twelfths I1. I just combined the 6I with the negative 247 twelfths I1. So writing this whole equation out, I have 7E over R equals 91 twelfths E over R minus 175 over 12 times I1. Now I have to solve for I1. I could subtract over this 91 twelfths to the other side. And when I do that, I get 84 minus 91 twelfths. The 84 comes from 7 times 12 from finding the common denominator, times E over R equals minus 175 over 12 times I1. Now I multiply by that reciprocal, and what I get is that I1 is equal to E over 25R. We're almost there. We're so close. So now we go back to what I2 was. And I2 as a function of I1, this is the equation that we derived just previous to this. This was 7E over 12R minus 19 over 12 I1. Now when you do this, this is 7 over 12. There's going to be a common factor, so I'm going to draw the parentheses. This is minus 19 over 12 times 1 over 25 times E over R, as like so. There's a couple of different ways to do this. If you just crunch through the numbers, you're going to find some cancellations happening, and what you end up getting is that this is 13 over 25 E over R, and so I want to write that. Whenever you've got a result that you worked hard for, what you really want to do is really write it nice and clean, because you should be somewhat proud of that. Okay, just like that. Okay, we're making steady progress. We are almost done now, because now we have I1 and I2. And from equation 3 that we had all the way back when, we had shown that I5 could be equal to 3/7 I1 minus 4/7. Oh, I have that backwards. Guaranteed to make at least one mistake, I guess. So this one was 3/7 I2 minus 4/7 I1. So there's a common factor of 1/7 there. Let's open some parentheses. This is 3I2 minus 4I1. This is 1. And then I2 and I1 both have a factor of 1/25. So this is 1/7 times 25. That's going to end up happening when you just plug those numbers in. And then the leftover factors are 39 minus 4 times E/R. Okay, so some more miraculous stuff happens. You get 1/7 times 25. I don't want to write out that full number because you're about to get some cancellations happening. You multiply this thing by 35, E/R. Of course, 25 and 35 share a factor of 5. And when you do that, you find that what's left over on the top is a 7. What's left over on the bottom is a 7 times a 5, E/R. And this is nothing but, of course, these 7's cancel. This is E/5R. So that's, despite all of those weird fractions that we were working with throughout the interim of this problem, what you get at the end is that I5 is equal to 1/5 E/R. Okay, that's a nice simple result. That's also what Jesse has. And so if you have that, I should probably give you the final number as well. But I think that that works. I believe I actually did not write those down, but you can plug them in. This works for any variation of those numbers. So hope that this was helpful for you guys. If you have any questions, please send me an email or contact me in some other way. Have a great day. See you when I see you.